Hello friends, welcome to Ashmit Academy. Today we'll see about the trees. So before that, as we know, in data structure, the data structure is divided into two. One is linear data structure and non-linear data structure. We already discussed some concepts of linear data structure. Now we'll see the concepts of trees. Okay, so trees, what is tree? Tree is non-linear data structure which is organized data in hierarchical structure, and it is also recursive definition. How see? We have seen the graphs, we have seen the different algorithm in graphs. So trees, as we know, in graphs there are the multiple path from one vertices to another. But in trees, there will be only one and only path between every pair of vertices, and that is known as the tree. And this is the difference between graphs and trees. Again, another property of tree is what? There should be no circuit formed in that graph. We have seen in graph that if the circuit is formed, it will be a graph. Next, some properties is there. Okay, so this is the example. If in such case, here A is root, okay, and this is tree. Why this is tree? Because there is no circuit formed in this example. But if you see this another example, here the circuit is formed between C, F, G vertices. Okay, and this is graph but not a tree. So there is a property of tree that there will be the only one path between the vertices. But in graph, we have seen the number of example of graph. So in graph, there are self loop on the vertices. Okay, there is the multiple edges from one vertices to another vertices. Okay, but in trees, no such multiple edges are there between the vertices, and this is the difference between trees and graphs. Next, we have seen the properties of tree, that every individual element is called as node. Okay, in tree we will call each element node. Again, we have seen the same concept in graph. If n number of vertices is there, then the edges will be n minus 1. So same concept is there in tree also. If n node is there, there will be n minus 1 edges. How? We'll see in the example. And we have discussed this last property, that is there is only one and only one path between every pair of vertices. Okay. So see the edges, we have second property, n node and n minus 1 edges. So here in tree also, see A, B, C, D, E, F, G. So how many? See 7 nodes are there, and if you see 1, 2, 3, 4, 5, 6, n minus 1 edges is there. Okay, so this is the property of tree. Now we'll move to the terminology of trees. What are the terminology? The terminology means the concept which is present in trees. Okay. So concept, let's discuss tree terminology: child, sibling, degree, internal node, leaf node, level, height, parent, subtree, forest, root, edges and depth. These are the terminology. Now we'll see each terminology in depth. Okay, so let's see the first terminology, that is child. What is child? The node which is descendant of some node is called as child node. Means what? The node which is present or which is the node of the parent, that is the child node. See the example. So this is the example of child. So A, B, C C, D, E, F, G. So G is child of C. Okay. D is child of B. In same way, B is child of A. So first terminology is child, and this is what child. Next we see root. What is root? So the very first node from where the tree is started or originate is known as a root node. Okay. In every tree, there will be only one root node. Okay, we have to keep in mind. We never have the multiple root node in the tree data structure. Okay. In graph, we consider any vertices as a root node, but in tree there will be only one. So root node. So example is what? A, from where this tree is started. Okay. In hierarchical structure, the tree started from A. So this will be our root node. Okay. Next, siblings. What are the siblings? So siblings is as same as the brother and sister from the same parent. In same way, the node which belong to the same parent is called as siblings. In another word, node will be the same parents are the sibling nodes. Okay. So these are the example. Same way, F and G are the siblings. So these both are what? The nodes from the same parent. Okay. And in same way, the B and C is the siblings because their parents are A. Next, edges. What is edges? So the connecting link between any two nodes is called as an edges. We have seen the same concept in graph as well. We have also seen if n number of nodes are there, then the edges will be n minus 1. We have seen the example. Okay, so the edges which will be connecting between the two nodes. Next is what is depth. What is depth? Depth is nothing but the total number of edges from the root. Now root node is the node from where the tree started. Okay, so that is the depth. So we'll see the example. Okay, so see, depth of B is what? 1. So number of edges from what? Here, root node. So number of edges from root node till B is how many? 1. So the another concept is parent. What is parent? So the node which has a branch from it to any other node is called as parent node. So we'll see the example. In previous we have seen the B and C is the child of A. Okay. So this is A is parent of B and C. In tree, parent node can have any number of child nodes. Okay, any number of child nodes. Next we see degree. What is degree? So the total number of children of that node, of that particular node, is known as degree. So see, it will be the highest degree of node. See, B having total number of children. How many children is there for B node? 2. In same way in C, 3 children is there. So degree of C is 3. Okay. Next, internal node. So what is internal node? The node which has at least one child. At least one child. So that is internal node. Again, this internal node is also known as the non-terminal nodes. See, why non-terminal nodes? Because if this B, C, D, A, this having at least one child, okay, and after that the node is there. The node is there. So this is what? Internal node. Next we see leaf node. We have seen internal node. Now we'll see in leaf node. What is leaf node? The node which does not have any child. Okay. So in previous video we have seen the A, B, C, D. These are the internal nodes because each node having at least one child. Okay. But here when the node does not have any child, then that is leaf node. Okay. We'll call that node as leaf node. Again, this is also known as a terminal node or the external node. Okay, why? Because no further child is there after or under this node. Okay, therefore this is what leaf node. Next we'll see what is level. So see, in every tree, each step from top to bottom. So top to bottom means from root till leaf node, or you can call it is what terminal node. So that is known as what level of tree. Level of tree. So the level count from will start from 0 and incremented with the 1. So a root node is there, that will be the your level 0.